That's offline. Hello?
Hello, sir. No one is responding.
I think there's something wrong. I mean, they are calling me
Okay.
on cell phone, and so actually they are conducting offline. Ours is online lecture.
Oh, okay, sir.
Online participants are only few.
Okay, sir.
Look at, there is a photo.
Yeah, there is. Yes, sir. So there are many people in the.
They are seated. I think they're all. It's a woman university.
Okay.
Yes, sir. Actually, we have centralized it one so that the students can also be able to listen to your lecture.
Excellent, excellent. So I see only students now.
Yeah, so a student with staff is also there. Research scholars is also there. We had took them together.
No, it's a woman university, right?
Yeah, yes, sir. It's
Oh, nice, nice. So Anita, you are the first representative on the model program. So we already reached 11:25.
Yes, sir.
So I'll cut off my presentation to an hour.
Okay, sure.
Depending on that, you just plan your presentation.
And according to, okay.
Yeah, you plan to wind up at least.
Yeah, so if time permits, I'll explain the result part. Otherwise, I'll highlight the data set creation
Correct. You just
and
plan
opening issues.
by 1 p.m. you should.
Yes, sir. Very happy.
You can go up to 1 p.m.
Okay, sir, sure.
We still have 90 minutes.
No.
I will engage for about 60 to 70 minutes and rest of things.
Sure, sir. So I will try to highlight the opening issues.
Yeah, you just see how many minutes you will get.
Sure, sure.
Okay. And my turn.
Sure.
Plan accordingly and wind up by 1 o'clock.
Sure, sir.
Guru sir, just give me 1 minute. I will check out what has happened.
Yeah, carry on. Why not?
I can access, but I don't know from there what has happened. Just give me 1 minute. I will just consult.
No issue. Take care because you should get it displayed there on the big screen, right?
Right. Sir,
Yeah.
ಬೇರೆ ಜೊತೆ ಕಾಲ್ ಮಾತಾಡ್ತಿದೆ. Maybe our earphones are ತಗಡಿಟ್ಬಿಟ್ರಿ ನಾವು.
ಯಾರು ಅಜಿಜವ್ರ? ಅಲ್ಲೇ ಹೋಗ್ಬೇಕು ಆಫ್ಲೈನ್ ಮಾಡ್ಬೇಕಿತ್ತು.
Offline, sir.
ಬಿಜಾಪುರಕ್ಕೆ ಹೋಗ್ಬಿಟ್ಟು ಒಂದು ಟೂರ್ ಹೊಡ್ಕೊಂಡು ಬರ್ಬೋದಿತ್ತು.
Sir, thesis ನಮ್ದು ಇದ್ದಿತ್ತು.
Right, submit ಮಾಡೋಣ. So when is your submission?
Sir.
Yeah.
ಸರ್ ಅದು ಇವತ್ತೆಲ್ಲ ರೆಡಿ ಮಾಡ್ಕೊಂಡು ಮಂಡೇ ಸಬ್ಮಿಟ್ ಮಾಡ್ತೀನಿ ಸರ್.
Oh.
ನಾಳೆ ಸೆಕೆಂಡ್ ಸ್ಯಾಟರ್ಡೇ ಇದೆ.
ಕರೆಕ್ಟ್ ಆಫೀಸ್ ಇಲ್ಲ.
ಹಾಂ ಸರ್, ಕ್ಲೋಸ್ ಇರುತ್ತೆ. ಮಂಡೇ ಎಲ್ಲ ಕಂಪ್ಲೀಟ್ ಆಗಿ ರೆಡಿ ಇರುತ್ತೆ, ಸಬ್ಮಿಟ್ ಮಾಡ್ತೀನಿ. ಸರ್ ಇಯರ್ಫೋನ್ ಯೂಸ್ ಮಾಡಲೇಬೇಕಾ ಸರ್? ಹಾಗೇನೆ ಪ್ರೆಸೆಂಟ್ ಮಾಡ್ಬೋದು?
ಮಾಡ್ಬೋದು.
ಇಲ್ಲ, ಡಿಸ್ಟರ್ಬೆನ್ಸ್ ಏನಾದ್ರು ಜಾಸ್ತಿ ಇರುತ್ತೆ ಸರ್ ಇಯರ್ಫೋನ್ ಯೂಸ್ ಮಾಡಲಿಲ್ಲ?
ಸಾಮಾನ್ಯ ನಾಯ್ಸ್ ಸ್ವಲ್ಪ ಇರುತ್ತೆ.
ಓಕೆ.
If your environment is noiseless.
ಓಕೆ.
ಎಲ್ಲಿ ಬರ್ತೀವಿ? you are at home or MIT?
ಸರ್ ಅದು MIT ಸರ್.
course. Hello? Yes, please.
Hello sir, am I audible to you?
Yes.
But ನನಗೆ sound ಬರ್ತಿಲ್ಲ.
Am I audible? Am I audible? Anita, ನಿಮಗೆ ಕೇಳ್ತಿಲ್ವೇ?
Sir, it is audible sir.
It's not audible for them.
Okay, that is Vijayapura.
Hello?
Sir, you are audible, sir.
One and all.
I think so. In the call, the problem is very on.
Welcome you all on the second day of CURIE-based International Conference on Artificial Intelligence and Soft Computing, organized by Department of Computer Science, Karnataka State, Akkamahadevi Women's University, Vijayapura. May I now request Mrs. Shilpa to please give an introduction of our guest. Ma'am.
Hello. Good morning, one and all. I am Shilpa Kavan, Research Scholar, Department of Computer Science, Karnataka State, Akkamahadevi Women's University. Welcome you all to the second day of International Conference on Artificial Intelligence and Soft Computing. It's a great honor to introduce today's eminent research person, Dr. D.S. Guru sir. Sir has come from a remote village, Devanur, Nanjanagud Taluk, Mysore district, and being son of a school teacher, and he has done his schooling in Kannada medium at Devanur. Sir's achievements are endless. I'm going to brief some of his achievements in his introduction today. Dr. D.S. Guru sir, he is currently working as professor and chairman in the Department of Computer Science, University of Mysore, India. He formerly worked as senior research scientist, Naimo Technologies Private Limited, Bangalore, and he has worked in several positions in University of Mysore. And his education background, he has done his bachelor's BSc in 1991 and secured 8th rank from University of Mysore, and he has done his master's MSc in 1993 from University of Mysore and secured 1st rank. And sir has done doctorate from University of Mysore in the year 2000 under the guidance of Dr. P. Nagabhushan sir. And right now sir is doing postdoctoral work at PRIP Lab, Michigan State University, USA. And he has received many awards, fellow Boy Scout from Department of Science and Technology, Government of India for the year 2005. And he is recipient of first ARP award under Engineering Science Vision Group of Science and Technology, Department of Science and Technology, Government of India for 2010. And he is recognized as Best Ethical Teacher at Higher Education by Rotary Mysore for the year 2011. And his research experiences are, sir has guided successfully 19 PhD students, and currently 6 students are pursuing PhD under him. And he has published 85 plus journals and 300 plus conference papers with the H index of 26 and 2626 citations. And he is member of advisory boards and program committees of several AI related conferences. And he has been editor for several international journals. And he is the author of several books like program solving with C, object oriented programming with Java, object oriented programming with C++. And sir is nominated by MHRD, Government of India, as member of Board of Management, Institute of Medical Science, deemed to be University Maharashtra. And he has been invited to deliver keynote talks, seminars and speech at many international conferences, seminars and workshops, including human resource development centers in India. And he has been visited to USA, China, Russia and France to deliver lectures. And sir is the founder, trustee of Maharaja Education Trust, Mysore, which has established various institutions in and around Mysore, including engineering colleges,
the screen? The screen visible? Is the screen visible?
Yes, it's visible.
Okay, so good morning to all. So it's my immense pleasure to participate in this international conference on AI and software. It is echoing, madam.
Yes, sir. So we are able to hear.
Yeah. Hello, Madam Rashmi, who is there? Huh? Hello? Hello?
Yes, sir, it is audible, sir.
ಕೇಳ್ತಾ ಇದೆಯಾ ನಾನು ಮಾತನಾಡೋದು? ಮೇಡಮ್ ರಶ್ಮಿ ಆమె ಆಡಬಲ್ ಅಲ್ಲಿ ಕೇಳ್ತಿದ್ಯಾ? ಯಾಕೋ ಆಗ್ತಿದೆ ಸ್ವಲ್ಪ ನೋಡಿ. And you sit with them and you just keep all others muted and you have unmuted audio so that you can respond to my query. Yeah, somebody can sit there please. Yes? Yeah, otherwise I myself alone continue talking here in my office. Okay. Yeah? Fine. So hoping that I am audible to all participants who have been seated there in offline, seminar hall. Good morning to everyone. It's my immense pleasure to participate in this international conference on AI and soft computing. A very catchy title and which talks about really a current demand in computational technology. And as somebody got me introduced to you all, I am myself Professor Guru from University of Mysore, pursuing research in this related areas for the last roughly about 25 years. And I have with me one of my good colleagues, Madam Anita Raghavendra, who is an associate professor at MIT Mysore, works for Department of Electronics and Communication Engineering. She has been pursuing a doctorate and submitting a thesis probably by next Monday. She worked on automation of mango grading, sorting, and internal defect detection using AI techniques. So she has great effort to make it possible to provide and propose AI-based solutions for post-harvesting, management of mangoes. So my concern, of course, though we have wasted roughly about 35 minutes for the next roughly about 80 to 90 minutes, my interest is just to give you the highlights of the work that has been carried out by Anita Raghavendra in specific, but in general, how we just have exploited the beauty of machine learning for sorting of mangoes, especially soon after the mangoes have been harvested from the respective trees. This work is accomplished for the last roughly about 4 years, and she could come out with some couple of good publications appeared in elsewhere journals. Probably those who are really motivated and inspired to take up some research work in this domain of agriculture in general can refer to those papers published by Anita and myself with added co-authors. So let me just begin giving you some highlights on this mangoes. Though mangoes are well familiar to all of you, the mango is one of the delicious fruits which is is really tasty, and everyone loves to eat. Even diabetic people always love to eat mangoes, though it is not advised. Generally, mango is full of sugar, and especially mangoes are not advised for diabetic people. But still, because of its taste, nobody loves to give it away, and everybody loves to take a risk of eating, the mango in spite of being diabetic. And that's what I'm talking about, the beauty and the taste of mango. It is one of the great delicious fruits, and happy to say that India has become one of the prolific growers of mango. Indeed, though the mango is grown even outside India, but India contributes beyond 50%, more than 50% of total production in the entire globe. So that's our strength, and India is recognized as one of the prolific growers across the globe, and the mangoes are used locally within India and sent out of India for international level. And unfortunately, if I remember, in 2014 and also 15, European countries have banned exporting mangoes from India to European countries, because that most of the mangoes that India used to send were not in good conditions. So either they were with the damages, they were with the serious diseases on skins, or they were with internal defects. Unfortunately, Indian government did not have automation of grading of mangoes, so separating mangoes which are healthy, which are good for consumption, from that of mangoes which are not good in their conditions. And because of that, the European countries have banned. And this mango, unfortunately, as we said, it is most one of the delicious fruits, but unfortunately at the other end, we cannot keep it for a long time. It is one of the perishable crop also, highly perishable. After 1 week, you cannot use that mango unless you preserve it in a proper way. So generally, the mangoes are harvested the moment the mango mature, and once the matured mangoes are picked up from the trees, and they will be put in some moderately temperaturely controlled environment, and then either they are chemically treated or they are allowed to naturally ripen. But most of the times, especially in Indian city, the mangoes are artificially ripened. So unfortunate that we use some chemicals spread across. We spray some chemicals on mangoes so that mangoes become ripened. That's not those mangoes are not healthy to eat and consume and eat. So importance is because it is highly perishable crop. We are going to spend good amount of effort, and we are going to take care of those mangoes after harvesting. So harvesting methods are really important. How to pick it up from the trees is one, and then what are the different steps involved in harvesting. Soon after harvesting, how we are going to take care of the mangoes. Soon after harvesting, the post-harvest handling is equally important. So for quality steps, especially the human being, the farmers, do take care of these, like desapping. I mean, once the stem or pedicel of mango is broken, the sap exudes out and spreads over the entire mango fruit peel, causing serious damage on the skin of the mango, resulted with serious threat to external quality of mangoes, which gets rejected. So desapping is really an important step which has got to be taken care, and then cleaning of mangoes so that they appear wonderfully well, and so that they attracts the consumers. Later on, because mangoes will be of different size, and mangoes will be of different color, and mangoes will be of different taste, based on their qualities, based on their sizes. We have to sort them and then grade them. And it is just to see that we will fetch a better market price. so that the farmer can sell it for a reasonably good price. Otherwise, farmers will lose it. So, in order to improve the price, in order to uplift the price of the mango, one has to take care of these quality steps, especially after post-harvesting. Unfortunate that even today in Indian scenario, these steps are being taken care manually. Okay, probably you just look at it, the bottom right side of my slide. I have a couple of pictures integrated, put together, where the human beings are involved in taking care of these quality steps. So, if I just now, for the sake of completeness, touch upon the steps involved in post-harvest management. First step is harvesting. Harvesting involves desapping and cleaning, as I explained, and then we like to put them into some controlled temperature and to protect them, and to preserve them, and then go for sorting, grading based on size, color information, shape, and in case if mango is damaged, that has got to be taken out from the pool, and then go for ripening. During ripening, we have two ways of ripening. One is naturally, allow the mangoes naturally get ripened. On the other end, because most of the times when you allow the mangoes to get naturally ripened, and I'm sure that out of 100 mangoes, only 40 to 60 mangoes will generally get ripened, and the rest of the mangoes will go wasted. So, because of natural temperature conditions, and unfortunately, because of that loss, in order to compensate, on the other hand, mangoes are generally treated, artificially treated, chemically treated, either by using calcium carbide or by using ethanol. Once these chemicals, are spread out over the mangoes over a period of hours of time, all mangoes at a time become ripened. All mangoes suddenly, all 100 mangoes ripened, so that we can release it for market. So once the ripening stage is over, then we go for packaging, and then we just pack it up and then put them into some storage for the purpose of transportation from place to place, so that we push them into market. And at the other end, look at, I'm okay with this as long as I'm the farmer, as long as I'm the producer. But on the other hand, when you look at it from the consumer point of view, consumer always worry about the quality of that. He has got, or she has got his own quality check. How do they, check with the qualities of mango? Basically, they look at what is the ripeness method being adopted. I mean, I being a consumer on the other hand, at the consumer end, I just want to have a mechanism to check or to predict, is it chemically ripened or naturally ripened. Always I prefer to buy the mango which is naturally ripened rather than going with buying of chemically treated mango. Then I require a method of predicting ripeness method. So which is the method being used? In case if it is chemically used, chemically treated, then is it calcium, carbide treated one or ethyl treated one. So I have to find a method. In case I'm looking for being a computer scientist and expecting you people to contribute in this field, so that you come up with an Android programming which would be deployed on a cell phone, a smart cell phone, which has got a camera setup. So while buying up mangoes, you just take up your smartphone, then click a picture. The moment you click a picture, my app has to tell me whether it is chemically treated or naturally ripened. So that's what I'm looking for. I mean, at the consumer end, there is a quality check, especially for predicting the ripeness method being adopted. The second one is it good to eat? Is it really ripened? Is it underripened? Is it overripened? In case of overripened, how much is that? What is the degree of ripeness of the mango? So ripened mango can be used only for a good 3 to 4 days. Even after 4 days, it becomes overripened. Earlier to 3 days, it becomes underripened. So is that the right time to consume that mango? What is the degree of ripeness? Can we estimate that? I'm looking for some model learning algorithms which are capable of looking at some known supervised in a supervised environment, some labeled mangoes, and then based on those, looking at those labeled mangoes, if the learning algorithm can acquire the knowledge and then finally help me out in estimating the degree of ripeness of an unknown mango, probably I'm happy being a consumer. So then another one is most of the times, if not in mangoes, you must have seen in apples generally that apple looks really good outside. It looks so reddish so that you will love to buy it. The moment you take home and then cut it off, you will see a kind of black soft tissue inside, so that the apple is not good to eat. Similar observation is true. Similar defect is possible in case of mango. Mango looks wonderfully well exteriorly, but the moment you cut it off, you will see some soft tissue inside, so that you have to throw it out. You cannot eat it. You cannot consume it for any purpose for that matter. So without cutting, can I just check whether this mango is really good inside or bad inside? I'm looking for such a classification algorithm which is capable of identifying in pool of mangoes. These mangoes are really good to consume, and these mangoes are having some internal defect inside. So then generally we have a technology called you just subject a mango for X-ray. The moment a mango is subjected for X-ray, and nobody loves to buy it because it is subjected for X-ray. That's not good for health to eat a mango or any food for that matter which has been subjected for X-ray. So then we are going to put a label on the mango stating that this mango fruit has been subjected for X-ray analysis. If such a label is placed on the mango, no consumer will buy it. Right? Then can we think of some alternative way of finding out if any internal defects in mangoes without subjecting for X-ray? But can we think of a different rays, different imaging system for that? That's another quite interesting research avenues which we have explored. So in case if mango, maybe because of the sap exudes and then spread across or over the mango, or it could be because of overripening, there could be some black spots on the mangoes. So you must have seen some mangoes having some black spots on the skin of the mango. The presence of black spot doesn't always imply that mango is internally defected. There are certain good mangoes, but unfortunately have got black spots, but internally they are really good, healthy to consume, good to consume. And there are certain mangoes where black spots are there, but internally also not good. Internally bad. And there are certain mangoes where no black spot on the skin, but internally not acceptable. So these are the different, samples which we can collect and train a model, so that model will understand classifying these possibilities. These are all the different quality checks that one has to think. The question is how to attend it. The answer is, can we exploiting the beauty of machine learning today, right? Can we think of AI driven solution to make or to answer all these quality check questions, so that consumer will have such a technology and to choose a mango of his interest, right? So this is what the overall proposal. Here is a pool of mangoes, and every mango will be placed on a conveyor belt. I'm explaining from the top left corner of the slide, level by level. So there is a conveyor belt which carries a mango from left end to the right end, and while mangoes are moved across, then there is a camera on top of that which captures the picture of those mangoes, and it will be connected to a computer, and computer will decide whether it is underripened mango or ripened mango. Automatically there has got to be a chamber which opens up for underripened in case if that mango is classified as underripened. Otherwise chamber gets closed and other part of the chamber gets opened up, so that in case if it is ripened, then automatically the mangoes will be moved, and then all underripened mangoes will be, will get collected in a basket, so that we need not use it for that purpose. Whereas the ripened mangoes will go to the other, location where there is another camera which captures the picture of the mango again, and then it looks at. That camera is made so smart, intelligent in just clarifying a given ripened mango into whether it is chemically ripened or naturally. Okay, and then again there will be two ways of passing through that. The mango will be bifurcated, and chemically treated will go one side, and naturally ripened mangoes will go on the other side. And next to that, then we are going to just check whether they are internally defected or not. So all internally defected mangoes will go to one basket, and healthy mangoes will go to the other basket, right? Whether it is chemically ripened or naturally ripened. Irrespective of it, in both this side we have the same setup. Same camera setup deployed, so that camera and the computer will decide whether it is healthy to eat or not good to eat. And this is ultimate, the process which we are proposing, and this is what is called sorting of mangoes or grading of mangoes. And amongst healthy mangoes which got collected in particular basket, which are chemically ripened or which are naturally ripened, based on your interest, you take up them, and then based on the size, based on the color, based on their volume, whatever it's you want to say, we can just again bifurcate them into multiple, pools, sub-pools of mangoes, sub-collections of mangoes, so that you can fix up different prices for each group of mangoes later on. So this is what, so these are all the locations where camera is set up, and really a machine learning algorithm has got to be trained and deployed for subsequent classification of some type of mangoes. Here are some pictorial examples of varieties of mangoes which I have already spoken of. So these are the pictures of naturally ripened mangoes. Look at, so within naturally ripened mangoes you see a kind of variable. I mean, the intra-class variation is reasonably high. And look at these are the pictures of mangoes which are treated by calcium carbide, artificially ripened mangoes. And within this class, you see a high degree of variations, and across the classes, between these two classes, you find some kind of similarities. But still, when you approach an experienced, farmer, that experienced farmer, we just have seen this in Devaraja's market. Probably Anita is right person to explain our experience. So we had seen the real farmers, experienced farmers, looking at the mango, telling us that, oh, this is chemically treated, this is naturally ripened. So in spite of there is intra-class variations and inter-class similarity, right? High degree of inter-class similarity. I mean, two samples of different classes look similar, and two samples of the same class look different. Unfortunately, that has really made this problem a complex problem for machine learning people. So these are the couple of more examples of ethanol treated mangoes. So you see that these are the three different classes we are talking about. I mean, first level is naturally or chemically. Under chemically, which chemical is used for that? If we can predict, then I can decide what is the goodness of that mango to eat, right? So these are some examples of mangoes which are internally defective. Look at on the left side, once mangoes are cut. So these are the soft tissue inside is noticeable only after cutting the mango. But look at, there is another mango on the top right, top line, second image, where there are some black spots on the skin. So on the right side I have unripened mangoes. These unripened mangoes will not be subjected for further classification, and they will be subjected for ripening process, and then will go. And these are some pictorial, image examples of varieties of mangoes we are talking about. This is an X-ray setup where mangoes are placed and subjected for X-ray, and X-ray analytics, would help us in knowing whether that mangoes are internally defected or not. But unfortunately, it is not acceptable in real scenario that nobody loves to buy such mangoes which are subjected for X-ray analysis. Okay, NR spectroscopy is another equivalent spectroscopic methodology which we have used and for the purpose of identifying if any internal defects in mangoes, and these are healthy. These such mangoes can be accepted for consumption. So ripeness evaluation, as I said, so there is at level we classify them into underripe, ripe, and underripe. Under ripened class we have perfectly ripened so that we can directly consume it. Overripened we cannot consume it. We can use it for different purposes like for manufacturing medicines, and so on. So within that we have mangoes having black spots and mangoes internally defected and so on. This Madam Anita would explain you better. So this is the general architecture we just are looking at it. Given is a picture of a mango, one has to pass through a pre-processing and segmentation, a kind of enhancing the quality of the pictorial appearance of the mango, and then segmenting the area of the mango and extracting subsequently the features. So you can think of extracting color features, texture features, shape features, NIR, wavelength spectrum, and today because of existence of all way of deep learning architecture, you can even think of deep features, and then subject it for classification. Let the classification algorithm learn the differences, between the samples belonging to different classes, learn the similarity existing between the samples of the same class, and then establish such a discrimination. Keep it in a library of knowledge, and when an unknown mango, is seen next day, then we do the same pre-processing, same feature extraction, then subject it for classification purpose, and then we just get the bank recognized. So this is a general architecture of the overall framework of the model that we are looking for. So if I now, for sake of completeness, if I touch upon the science of machine learning, I would love to say that basically any machine learning setup has got 4 different components. One is what is called a sample called input sample space. The other one is what is called the label space. I mean, the input sample space is a collection of all possible types of varieties of macrocycles and belonging to possibly ripened, under-ripened, within ripened class, over-ripened and perfectly ripened. So they basically 3 classes. I mean, if you look at this, dendrogram, then hierarchical tree diagram, there are 4 classes: under-ripened, perfectly ripened, black spot without internal defect, black spots with internal defect. So all of them have got a black spots, but these are all the samples having internal defect, and these are all the samples without having any internal defect. Then possibly I'm looking at the 4-class problem, right? You take up such 4 classes of samples here, and then you have 4 different labels. That collection of possible labels is what's called label space, and there is a mapping, a distribution x to y, and that distribution is generally unknown. The distribution is generally unknown, right? And then I am looking for a system which predicts possible labels. The moment I predict it, I have some general ground truth, and I compare it against, and what is the difference between the predicted value and the actual value? That's what is called error. That's what is the loss, and there is a loss function. So the job of machine learning is somehow given are some examples of this mapping x to y. Not all possible mappings exist. Given are some examples of mapping, some samples of this distribution, and I have to predict a hypothesis, which minimizes this loss function, right? Minimizing this. I mean, ultimate job of a machine learning is to train an algorithm called machine learning algorithm, so that the machine learning algorithm works and try to generalize this distribution, try to predict the labels accurately, so that the loss function will be minimal. That's what it is. I mean, looking for that. When I am looking for that, it's basically a searching problem. I have to search in a search space. The search space is of very use of the power by x. As the number of samples in the input space and the number of labels in the output space increases, the search space also increases exponentially. Unfortunately, that's a big problem. So, but unfortunately, as we cannot consider the entire space for searching, we just restrict our space to a minimum possible. That's what is called H. I'm trying to look at actual value. Actual hypothesis expected is the ground truth HG, but unfortunately, I just look at in the subspace, which is not covered inside, and then this is what is expected hypothesis, but on the other hand, this is what is the hypothesis gets computed, but my algorithm generate this H2 as the output hypothesis. Look at here is the difference. The right line segment connecting HG and HE, HE and HC, SC and HO. These are all different types of errors. Ultimate job of a machine learning algorithm is somehow to reduce this possible errors. Right? It could be overfitting, it could be approximation error, right? Whatever that. Ultimate job is to reduce the possible errors so that I can generate correct labels for the unknown samples. So this is a science of machine learning. So classical machine learning algorithms have been explored for many related applications for the last roughly about 40 to 50 years. So all machine learning algorithms work in Euclidean space. That's our assumption. And in reality, human brain, human vision system works beyond Euclidean space. But in computational science, we are supposed to exploit only the beauty of Euclidean space. They all are designed using Euclidean model, and they work on linear hypothesis stating that there is a weight matrix W and there is an unknown feature vector of a sample X, and when I do a linear operation on that vector X with use of this linear operator called W, then I generate the automatically I get the Y, which is the label. Look at it, could be a least square regression, it could be a decision tree ensemble, or it could be a support vector machine. Look at in the support vector machine, green spots are the samples of one class, blue spots are the samples of another class. The ultimate job is to draw a line separating these two samples of these two classes, maximizing the margin between these two and keeping up the equidistance from the samples of both the classes, so that that line can be used as a classifier. So all this machine learning, classical machine learning algorithms all are designed to work in a linear space, but unfortunately most of the times the samples belong to different classes are not necessarily linearly separable. You cannot think of drawing a line separating the samples of two different classes most of the times. In such case, we have to inevitably go with the kernel functions, where kernel functions convert this samples in the feature space where they are not linearly separable, move them or map them onto a different space where the samples become linearly separable to the extent possible. So such is what is called kernel functions. So today we are with luckily with many different architectures called deep architectures. So deep learning also works in a linear space and non-linear space, but the difference between machine learning and deep learning is that because deep learning works with millions of the parameters, obviously the search space considered is reasonably big. Whereas in case of conventional machine learning, we work with only limited number of parameters. Because I work with a limited number of parameters, the number of dimensions of the space where I am looking for my solution is less. Whereas in case of deep learning, because it has got millions of parameters, the dimensions of the search space is used. As the dimension increases, or the search space increases, then the probability that the expected hypothesis is very high. That's how today the deep learning are really working better than most of the machine learning algorithms. So they work in non-linear hypothesis space. It could be a fully connected network, it could be a convolution neural network, it could be a recurrence neural network which captures the temporal information of samples, and they have a gallery of deep learning architecture like AlexNet, ResNet, and their variants, BootleNet, InceptionNet, YOLO, SSD for detection, probably. Given is a picture of a tree with multiple mangoes, then I have to locate, I have to figure out only the areas of mangoes. So you can use YOLO, you can use SSD for detection. There is a gallery of deep topologies. So unfortunate that on the other hand, though it is considered to be really good, the lucky that we have got so many architectures working fine for most of the computer vision applications. But which architecture is really suitable for my application, especially for my environment in real time? That's more important. Searching for a suitable deep learning architecture has become now an hot area for researchers. Okay, that's another topic of research, for example. So anyway, so whether you work with machine learning algorithms or you work with deep architectures, most of the times we end up generating many features, but most of the features are irrelevant. Most of the features are not relevant, right? And there should be one feature which could be a linear combination of the others. If that is the case, why do I keep it? Or there could be one feature which has got a high degree of correlation with another feature. Why do I keep both? Can I think of throwing out one and retain only one, so that I can compress the number of features, I can reduce the number of features. So that's what the dimension reduction methodology is. So basically there are two types, majorly two types of dimension reduction methods. One is the feature selection, where I end up selectively choosing the best out of several, and another kind is just transform n number of features to some k number of features, where k is reasonably small when compared to n. I mean, I just end up working or generating a new set of features, but less in number when compared to the original number of features. So this is the big difference. So in feature selection, as I said, it's a subsetting. If I get a n number of features, a set of n number of features, obviously there shall be 2 power n number of possible subsets. And because 2 power n possible subsets, one of those subsets could be the most optimized features collection. So how do I look for such an optimized feature subset? Obviously it's an exponential type complexity. I cannot see that. I try with all possible subsets and then evaluate this learning algorithm for its performance, and whatever the subset which drives that a learning algorithm for maximum performance can be selected. No, it cannot, practically not visible. Then I have to go for some optimized way of looking at it, right? Like genetic algorithm can be exploited, dynamic programming strategy can be exploited, right? So I have to use some algorithmic strategies to choose the best subset with a compromising nature that if I don't get into a best subset, at least I'll get into a nearer to that, something approximating that. So approximation algorithms have come into picture, have been published in literature. There are many different feature selection approaches. On the other hand, As I said, with the transformation, it takes up the original set of features and then a transformation is applied, and the transformation is expected to get us these features transformed. I mean, into another set of features where number of features is reasonably less when compared to the number of features in the original space. And here, after transformation, every feature which is computed is a function of all those. So that's what the feature transformation. So here is some example for feature selection. I have on the left side, n number of samples, let's say 6 samples expressed by 10 features, but I don't want all 10 features, I want only 3 features to be selected. Then I have got F2, F5, F9 selected. These F2, F5, F9 columns are originally present in the left side matrix. This is what is called feature selection. So an example could be this. Look at here on the 8 samples, S1, S2, S3, etc. 8, and each sample has been described by F1, F2, F3 features. So you cannot use any one of these or any 2 or any all the 3. Is it really required to have all the 3? Then we understood that F1, F3 are good enough to distinguish these samples and uniquely identify them. So then 1, 6 and no other samples share 1, 6, 8, 6 is X, or the 2 features describing S2 and no other sample have got the same values 8 and 6. Hence, you need not have all the 3 features. It's good enough to have only 2 features, F1 and F3. Look at F1 column is already present in the original, F3 is already present in the original. Hence, I say it is a subset of that. Whatever you end up selecting, that selected features are originally present, and this method is called feature selection. This method is called feature subsetting. On the other hand, if you look at a feature transformation, so apply some T so that it doesn't select it, but it gets you new values computed. So unfortunately, look at these 8 samples, and no one feature alone is good enough to discriminate, because if you look at F1, then there are 2 samples, S1 and S3 having the same value 1, and there are other 2 samples, S2 and S4 having the same value 8, right? So F1 alone cannot discriminate all the samples. Similarly F2, because 15 and 15 are there for 2 samples. F3, 6, 6, 6 are there for 4 samples, right? So you cannot use any one of these features as a discriminating feature. If you try with 2, F1 and F2, it is 1 and 15, there is S5, 1 and 15. If it is 8, 15 in case of S2, there is another S6, 8, 15. So F1 and F2 together can also be not used to discriminate and identify any sample uniquely. And similar observation is true when you go with the subset F2, F3, or when you go with the subset F1 and F3. I mean, indirectly I am telling you that in case you want to discriminate all these 8 samples from the rest of the samples, then you have to use all the 3 features. But I don't want to use all the 3 features. Then can I use some transformation? Can I apply some transformation T which takes each triplet here and then produce 2 values as output? So then I just applied some transformation T. Let's assume that for 1, 15, 6 a triplet get transformed to 41 and 1440, 58. Similarly, second triplet is mapped onto another pair. I mean, here every triplet is mapped to a corresponding pair. Now, what is a transformation? If I tell you, it is a transformation with which you are all well familiar. Here the triplets are considered to be the coefficient of a quadratic equation. Ax square plus bx plus c equal to 0. So F1 is considered to be A, F2 is considered to be B, F3 is considered to be the coefficient C, and then quadratic solver is used and the roots are computed, and what is displayed in lowercase f1 and f2 on the right side, those are the roots of the quadratic equation. Look at this quadratic solver can be used as a dimensionality reduction technique, especially feature transformation technique. And now all samples are discriminable using only these 2 values. So this is how the kernel functions also sometimes work. When you understand that the samples are not linearly separable, non-linear boundary has got to be drawn, then you can think of boosting up the dimension. When you boost up the dimension, I mean, I am indirectly telling you that it is not a dimensional reduction directly, but in order to accomplish reduction in dimension, I am going for enhancing the dimension. Enhance the dimension from 2D to 3D so that samples become more clearly separable, and then project under the respective a plane so that again they are re-expressed in terms of only 2D. Look at the top right, we have red dots followed by green, dots. But when you the kernel function, just pull up the red dots so that in 3D space the red dots get separated from the green dots. The moment they get separated, then project them onto the vertical plane, and after projecting you will have a clear separation so that you can use a threshold differentiate red dot from that of green dot. Right? So this is what the kernel functions. Kernel functions try to achieve a linearity even if in the feature space the samples are non-linearly separable. How do? They try to, the kernel functions try to map them from the dimension to a higher dimensional space so that discrimination is possible, and then project them into a respective plane or lower dimensions. That's what. So feature selection methods basically there are fundamentally two: filter method and wrapper method. The difference is the filter method is a learning algorithm independent. I end up selecting the features independent of learning algorithm. Whereas in case of wrapper method, I end up selecting features based on the learning algorithm. I mean, in case of wrapper method, I must know in advance which is the learning algorithm I would be employing. Whereas in case of filter method, needless to worry about learning algorithm, you just based on the property of the features, you just end up selecting. I mean, exactly like selecting the cricketers for making Indian cricket team playing for an international World Cup. Then we don't worry about who are the opponents. We just ended up selecting 11 players. On the other hand, if Indian team has to play against Pakistan, only 3 matches, that all the 3 matches are against Pakistan. We know who is the opponent, and by keeping in mind the strength and weakness of Pakistan players, if we end up selecting the cricketers within India, then I say it's a wrapper. So this is the difference between. In case of filter method, I don't worry about which is the subsequent learning algorithm which would be employed. Whereas in case of wrapper method, I worry a lot. I mean, while selecting the feature, I keep in mind this is the learning algorithm. If no, SVM is the learning algorithm, so I end up selecting somehow. If nearest neighbor is the learning algorithm, then I may select a different set of features. So these are the major difference between filter method and a wrapper, and these are the fundamental primary methods of feature selection. So whereas in case of filter method, because I do it independent of learning algorithm, I have to have some criteria for selection, and such criteria is what is called feature selection criteria. Whereas in case of wrapper method, because I select based on the learning algorithm, then what is the condition used is based on the performance of the learning algorithm. Means here in this wrapper method, performance criteria of learning algorithm is required. So most of the times we neither work alone with filter nor alone with wrapper, and we just combine them together. That's called hybrid method. And sometimes I combine 2 different filters together, or 2 different, many different wrappers together, and such methods of combining is what is called ensemble method. Ensemble methods are fusing of same like filter to filter, wrapper to wrapper, and so on. So this is the diagrammatical explanation. And filter design basically 2 steps. One is select relevant features. You may end up selecting 100 features out of 1000. But amongst 100 features, because you ended up selecting based on the ranking criteria, and there may be 2 features which are highly ranked, but at one is highly correlated with the other. Then try to find out such redundant features and then eliminate. That is the second step in a filter design. So for the purpose of finding out the relevant features, you have to go for a dispersion measure. I mean, for each feature, compute the score, like generating a ranking list of all students applied for PG admission. We just sort those students. I have only 20 seats. I will end up selecting top 20. Who are the toppers? Then we just rank those. Sort those students based on the degree score. Similarly, here for every feature, I have to compute some score, and based on the score, features get sorted out. And once features have been sorted out, we just select the top, right? M features. So select the top M features. Among these top selected M features, there can still be redundant features. So how do I generate score from this? We can use mean absolute difference. We can use variance as a measure. We can use standard deviation as a measure. We can use arithmetic geometric mean ratio of the features values. We can use mean median difference in each feature, right? You have a Fisher ratio in case it is a supervised environment. You have a different set of possibly different dispersion measures, dissimilarity measures to generate the score for each feature, and based on that you can think of sorting them. Once top M features are selected, then try to identify similarity within them, and whichever the 2 features which are found to be highly similar, instead of having both, you can just remove one of them. Right? So then I get eliminate redundant features. For the purpose of eliminating redundant features, I get use degree of similarity, a measure of similarity, and cosine similarity or correlation coefficient, any such measures, which any metric which helps you in computing the degree of similarity can be used for this purpose. So these are the basic steps. Alternatively, you can think of, you take up all features which are 1000 in number and group those features based. You do a cluster analysis of features. Generally, we do cluster analysis on samples to understand and explore the internal relationship existing among them, right? Here, you take the features as samples and do cluster analysis, try to group the most related features together into one group, and from each group, you end up selecting one representative. Suppose I have 1000 features clustered into only 5 groups. Then from each group I select 1, 1, 1. Then I ended up selecting only 5 features. 1000 features have been reduced to 5 features. By selecting the cluster representative, if you end up selecting one of those available or 2 of them available, then I say your method is a feature selection. Instead of going for selectively choosing one of them in each group, if you compute the new representative for each group, then I say it's a feature concentration through clustering. So this is how it works. You can do agglomerative clustering, or you can go with the partition clustering. K-means is really exploited for this purpose. You choose a representative, and that representatives are assumed to be the ultimately selected features. Right? So wrapper methods, as I said, they work with the support of learning algorithm, and learning algorithms performance criterion is used to decide whether a given feature is the feature to be selected or feature to be rejected. There are basically sequential forward selection, sequential backward selection, right? And hybridization of that. So basic difference, sequential floating forward, backward selection. Look at method of, it works with the method of inclusion, whereas the other one works with the method of elimination. So it starts with an empty set, whereas it starts with also. It goes on selecting features, right, by adding up, whereas the other one goes on eliminating one by one. Whereas in the ensembling, I use inclusion followed by elimination, whereas the other one is an elimination by inclusion and so on. This is the difference between exploiting different wrapper methods. So principal component analysis is the most popular feature transformation technique, which is exploited for the maximum benefits in most of the applications. Unfortunately, it is an unsupervised learning algorithm. So given are these 4 samples, look at here, S1, S2, S3, S4. So each is a point in 2D. Being a point in 2D has been described by 2 coordinates. And in case if you want to distinguish S2 or S1 or S3 or S4 from the remaining 3, you have to use 2 coordinates. Because S3 and S4, they do match with the X value. Whereas S1 and S4, they do match with the Y value. S2 and S3, they do match with the Y value. S2 and S1, you cannot distinguish with either X value alone or with Y value alone these 4 different points in this 2D. Then what do? I just want to find another plane, let's call it as PC1 and PC2, where PC1 and PC2 are mutually orthogonal. There is a new set of basis vector I am looking at, so that if I get these S1, S2, S4 projected onto one of these 2 axes, and the projected points become discriminable, right? Projected point become discriminable, right? The moment you project it, look at D1, D2, etc., they are the newly computed coordinates for these 4 samples, and those are good enough for me. Now these 4 samples can be, distinguished only with single value. That's what is called principal component. So in my style of presenting PCA, if I tell you that, imagine that you are all seated in a auditorium, and there is a professor standing on the dais in front of you. When that professor looks at you all, unfortunately, because you're all seated one behind the other, so that professor may not be in a position wherever he is standing, with respect to that position, he may not be in a position to see everybody's face, because somebody's face is hidden because of the presence of another person in front of him. Then I expect the professor to, move across on the dais and try to, get shut down in some position on the dais so that everybody's face is visible. everybody's face is completely visible for that person. Yes, I expect the professor to get relocated. That is what is called a new set of basis vector we are computing. And the PCA generally, most of the researchers are using as if it is a black box. It takes n number of features, produce equivalently n number of transformed features, and in a sorted order based on the relevancy, because automatically the PCA gets you those computed features sorted based on the degree of relevancy. Just end up selecting the top d number of features of your interest, right? The computation is so simple. Let F be a feature matrix, compute the covariance matrix of that F, let it be M, and just go with the eigen decomposition of that covariance matrix of F, generate n number of eigenvalues and eigenvectors, and project those original features onto those eigenvectors of the top largest d eigenvalues, so that you just ended up computing d values for each sample of your interest. That's how the PCA works. But unfortunately, PCA works in unsupervised environment. Class labels of the samples are not being used here in PCA, but sometimes we have to take into account class samples also. So most of the times PCA, in some examples, PCA will not issue most discriminable features, unfortunately. So then we have to go with some supervised learning algorithm called Fisher linear discriminant analysis. It's also called linear discriminant analysis, FLD or LD, you can call it as, which exploits the beauty of this discrimination by the use of class labels. And this algorithm is generally called supervised learning algorithm. So in our Mango grading, Mango feature selection, especially in transformation technique, I'm sure that Anita has explored possibility of making use of this Fisher linear discriminant analysis to end up selecting the best wavelengths for identifying interdefected members. So I now request my colleague, good friend Madam Anita, to go with this experimentation and result analysis for about 20 to 20 minutes. Madam Anita?
Sure, sir. Yes, sir.
Shall I stop?
Yes, sir. Am I audible, sir?
Yes. Yeah. Now you can share your slide.
Yes, sir. Screen is visible?
No, madam.
Yes, it's
visible, madam?
Is it with the same experimentations and result?
Yeah, yes.
For me, it's not visible. Maybe it's here. Yes, visible. Yeah.
It's with the text.
Yeah. You go with the F5 now. You just put it in.
Yeah, sure. Just okay, sir. Is it okay, sir? Now?
Yeah,
Yes.
Carry on, but put it in presentation mode.
Yes, sir. It is in presentation mode only. It is in full screen. Okay. Good morning, everyone. I'm Anita Raghavendra, research scholar, University of Glasgow. There is some disturbance.
Yes, ma'am. Welcome you to the 3 days international conference. You can continue the session, ma'am.
Okay. Yeah. Thank you, ma'am. Thank you.
Yeah.
Okay. So in Mango grading and sorting problems, sir has already highlighted the problems which I'm explaining here. So I would like to present experimentation and results related to that. And the thing is, for the purpose of collecting the data set initially, so we have taken nearly 250 mangoes, so directly from the farm. And actually why I presented this slide as a first slide is because I just wanted to highlight the difficulties which I have faced during the collection of data set. And when we have purchased the mangoes directly from the farm and So we had kept it for ripening process. So after 3 days, after 3 to 4 days, so when we just observed the mangoes, so when we just looked into the mangoes, so mangoes were almost like this. So you can just observe here, so which is at the picture, which is at the bottom left corner. So out of 250 mangoes, so almost 200 mangoes were completely decayed. Then we went behind. Then we went like so. Hello.
Yes, yes, you're right.
Yeah. Okay. Yeah. So then we went behind searching the reason of this decayed mango. So then we got to know that because of this hailstorm. So this you might have observed, especially during this season. So because of this reason, so like almost 200 mangoes were completely decayed. So I mean, this was the great difficulty that we have faced during the collection of mangoes. And later, also we have purchased mangoes directly from the market.
Excellent results from
Yeah, yeah. So stop sharing again, share.
Just a second.
Stop sharing.
Yeah, now, yes.
Now it's go with slide presentation. It's
Okay. Okay, now it is.
Yeah, you can just put the slideshow, like,
slideshow.
Yes, sir. I've given slideshow only.
yes.
Oh my God. Okay, you carry on.
Okay.
Okay. So as you can see in this table, so like 230 mangoes were kept for ripening process, and on day 5, so some mangoes were ripened, and which we have considered like as under ripen, and after like 7th day, so some mangoes were again ripened. And when we just observed the mangoes after the 9th day, so mangoes were completely ripened, and we call it as over ripened. And when we just observed the mangoes, so some mangoes were like under ripe. We have just categorized based on the observation. We have just categorized the mangoes as under ripen, then ripen one. And similarly, after 9 days, so we have observed some mangoes were completely ripen, and we could find some black spots on that. And as sir explained, so on some mangoes we could find black spot, but still internally the mangoes were good. But because what happens is, especially in fruit industries, so these kind of mangoes being discarded and assuming that there is a problem in the mango, even internally. So even like we thought that based on this observation, we thought that so why don't we separate these kind of mangoes? That means black spotted mangoes with internal defects and without internal defects. So and with this actually, so later we have proposed a hierarchical model considering in the first level classifying under ripen and ripen one, and in the second level considering the perfectly under the ripen one, considering classifying perfectly ripen one, and then overripe like mangoes with black spots. And in the last stage, so as you can observe here, so in the last stage, so we are able to classify the black spots without internal defects, then black spots with internal defects. So we have proposed hierarchical model to classify 4 different classes of mangoes. So based on the data set which we have got. And here, here actually the temperature, temperature or moisture, that is humidity and cooling effect is not considered. So I think in future, so one can think of analyzing all these parameters, because these parameters are very, very important. As we all know that temperature, because for less temperature, so we need to analyze how fast it gets ripened, the mangoes gets ripened, and how fast or how slow it gets ripened, and similarly for high temperature. So even these analysis should be done. And also along with these, along with considering these parameters, ripeness evaluation plays a very, very important role, especially during transportation, because here for that is for for export purpose, or just a second. So there is a demand for mango both that is locally and internationally. So there is a demand for mango both locally and internationally. So we need to transport export the mangoes to different countries. We need to export the mangoes to different countries. So based on the distance between the places. So when we just looked into the distance between two places and the time taken to transport to different places, so that means packing the right stage of ripening stages of mangoes is also very important. So with this, actually, the ripeness evaluation plays a very important role. And when we come to the result part here, for these mangoes, like we have extracted 5 different color space features like LAB, RGB, HSV, CMY, then YCBCR. So we have extracted the individual features like L individually, A, B, and then we have taken the fusion of these features. And the first graph indicates only for the first level. So first level means classifying, under ripen, and then ripen one. And similarly, the second graph, and these are trained with these are trained with 5 different classifiers. So we have used 6 different classifiers. That is LDA, SVM, Bayesian, KMN, then probabilistic neural network. So along with these 5, so we have come up with a new classifier, that is a threshold-based classifier. So based on the threshold between 2 samples, so even the samples are classified. And this is the graph for the third level. Third level means classifying overripen with that is black spots with internal defects and without internal defects.
Your slides are not coming up in order.
Oh, is it, sir? Actually, I'm changing the slide, sir.
Just
It's on data creation.
yeah, data set creation.
Yeah, now it is. Yes, now it is.
I think if I just put it in the slide mode, I would think it is not changing, I guess.
Okay, you do one thing. Anyway, we are not seeing the slide mode. We are seeing your edit mode only. Okay.
Okay, sir. Is it okay, sir?
That's fine. You go ahead with that edit mode only better.
Sir, is it possible?
Kept it for slide mode.
Pardon?
Is it possible? Yes, sir. Is it possible to make it a slideshow? Like it would be better.
Do one thing.
Is
You
it?
just stop sharing, Anita. I'll share the slide.
Sir, I have one more slide.
Except the last slide which you are interested in, we'll get back to you.
Okay, sir. Sorry, sir. I'll stop sharing this.
You just stop sharing.
Yes, sir.
Closing my slide now. Entire screen. Yes.
So let me try one, sir.
Just a minute. Okay. Is the screen visible now? Hello? Is the screen visible?
Yeah, it is visible, sir.
Yeah. What are you seeing now?
The experimentation it is.
Okay. This is what you want?
Yes, sir.
Okay, go with this.
Yeah. So, okay, when we come to the result part, we have tried with 5 different color space features, LAB, RGB, HSV, CMY fusion, ICBCR. And the first graph indicates that is for classification.
Yes, sir. Not yet.
Pardon?
Yes.
Carry on, Anita. I think she speaks for somebody else.
Okay. Yeah. So the first graph, this is for the classification of the first level of mangoes. So first level of mangoes means classifying under ripen one and ripen one, and similarly the second one. So we have followed the same technique for throughout all the levels, like first level, second level, and third level. And next slide. Okay, so and as we have observed here, so LAB color feature is contributing more for classification. To have a better result, and that you can just observe it in the blue graph. So here LAB, we are getting good result using LAB feature compared to rest of the color feature. And just to check the effectiveness of the LAB color feature, so we have also compared this color feature along with the texture feature. So considering texture feature as LBP, local binary pattern, next the GLCM, gray level matrix, and Gabor feature. And you can just observe here in the first level, LAB feature is giving us a good result, and in the second level, actually texture feature is giving good result. You can just observe that. So that is LBP compared to LAB, so we are getting better result using LBP, GLCM and Gable. Because why we are getting good result using texture feature is, the second level classification is classifying the perfectly ripened one and over ripened one. So when we consider these two, so perfectly that is over ripe, we can just observe the wrinkles on the over ripened one. So wrinkles means, of course, it's a matter of again texture. So because of this reason, we are getting good result in using texture feature compared to color feature. And again in the third level classification, that is classifying black spotted with internal defects and without internal defects. So we are getting better result using again color feature, that is LAB. But since there is no consistent result using texture feature, so here finally we are proposing LAB as a good feature for ripeness evaluation of mangoes. Next slide. Okay, in the same manner, so here we have tried with 3D plot considering LAB features. So you can just observe here. So black, that is red, red dots indicate underripe, and then the green one perfectly ripened one. So and as you can observe it in the table, so we are getting 99%, and which is mentioned in bold letters. So 99.09. So we are getting good result and classifying underripened one and overripened one. The same thing can be observed even in the graph, even in the 3D plot. Here the red line can be easily separated to rest of the colors. So we are getting better result in the first level, and in the second level we are getting 85.94% of accuracy. That means classifying perfectly ripened and over-ripened one. So again, it is quite less compared to the first level. And in the third level, so we are getting, because, and we have also we have taken only a less number of samples in the third level. So we could get only less number of samples at the third level. So we are getting the 80.28%. And to find the accuracy of the whole hierarchical model, so we have taken the mean accuracy, that is weighted average equation. And finally, we have got some 86.87% of accuracy in this model. And again, to check with the effectiveness of hierarchical approach, so we have also compared this with the single shot multi-class classification. Because multi-class means, so we have 4 classes. We have compared this with the single shot multi-class classification. So here also we are getting better result using hierarchical approach. So this model has not tried out in any earlier research form. And we also compared our proposed model with the existing models and the literature that we have found. So, and in most of the literature, so they have not addressed underripened one. So most of them have addressed unripe, then ripe, then overripe. But here, apart from these categories, so we have taken here underripened one, that means mangoes under the ripe. Next is we have taken overripened one with black spots. Then after this black spots, we have also considered the data set as black spots with internal defects and without internal defects. And we have also collected nearly 230 mangoes. But finally, so we have taken 973 images. So we have tried with these images. Next. And next is categorizing artificially and naturally ripened mangoes. So here also we have taken 2 different varieties of mangoes. One variety as badami and another variety as raspberry. And in one category of one variety of mangoes, so we have taken 3 classes. As sir explained, we have taken naturally ripened mangoes, calcium carbide treated mangoes, then ethyl solution treated mangoes. In the first category, so we have categorized naturally treated and calcium carbide treated mangoes, and in the next natural with calcium, one is natural with calcium carbide and another with natural with ethyl solution, and under raspberry again the same steps we have followed. So here we have tried with the combination of features, because we were interested to so come out with the best of color feature and best of texture feature. So we have tried with the combination of features, and to have this combination of features, we have considered all 5 color space features like RGB, HSV, NEB, CMY, YCB is here. So in the first step, we have taken the combination of two color features like RGB, HSV, and similarly, like it's something like 5C2, 5C3, 5C4. So we have tried with the combination of these 5 features. So we have obtained nearly 69.89 to 85.72% of accuracy for the best of color feature. And you can also just find this combination of color feature in the table. That is example in badami, so natural, it is the first part is calcium carbide treated mangoes. So there, yes sir. So we have a combination of CMY and HSV. So combination of CMY and using this combination of CMY and HSV, so we have obtained 69.89% for classification of natural and calcium carbide treated mangoes. The same steps we have followed for the rest of the classification. And similarly, we have also tried with the texture features. So combination of texture features. And so here we have obtained the 70, same model we have used for texture feature again. So we have obtained the 75 to 79% of accuracy for the best of color feature, best of texture feature. So you can just observe it in the second table. So combination of heraldic, that is DLCM feature, and Gabler feature, that is for the classification of natural and calcium carbide treated mangoes. And the first data set we have collected during the year 2015, and we have also collected another set of data set during the year 2018. So we have tried with deep learning technique for the second data set. So this is the result of deep feature-based classification. So here for the second data set, that is data set 2, so we have extracted features using deep learning, deep neural network based technique. That means using AlexNet, GoogleNet, ResNet 50, ResNet 101, VGG 16, VGG 19, and Inception V3. So we have extracted features using only deep neural network based architecture, then classified using SVM, support vector machine. And we can just observe here. So we are getting a better result using ResNet 50. And we have also tried deep learning for the first set of data, that means data set 1. So there, actually using convolution method, we have got maximum accuracy of 85%, but using deep neural network based classification, so we have obtained, we have achieved nearly, so that is more than 90% of accuracy. So, yes. And when we come to the next problem, that is internal defect detection, so this is a very challenging issue because outside it doesn't look so the defected one. So outside it looks very healthy, but inside when we just cut it open, so we find a spongy tissue. So we also call it a soft tissue. So you might have observed that white patches inside the mango. And here, this is not the image. We have collected different type of data here using NIR spectroscopy, that is near infrared spectroscopy. So wavelength ranging from 700 nanometer to 2500 nanometer. And this is the setup we made in the laboratory. Yes. So here also actually we had a great difficulty, especially while carrying the mangoes from because the setup was available. The setup was made in Bangalore, so from Mysore to Bangalore, so we had to carry the mangoes. And because we were not knowing which was internally defected and non-internally defected, so when we just asked in the market, so they just picked randomly, they just picked some random mangoes, and finally we had to carry from Mysore to Bangalore. And while carrying these mangoes, worms were coming out of the mangoes. So that was another difficulty that we have faced. And so that is why we could get very less number of samples here. And this is what we have observed as an internal defect in mangoes. And we had to cut all the mangoes to create the ground truth for our experimentation purpose. So based on the ground truth, so it has been categorized as the internal defected one and the non-internal defected one, that is healthy one. And the data which we have obtained, so that was in the form of reflectance versus wavelength. So as I told, the NIR spectroscopy wavelength ranging from 700 nanometer to 2500 nanometer. Since we had two different optical fibers, so we could get the lower range wavelength that's ranging from 650 nanometer to 1100 nanometer, and the higher range wavelength, so that is from 1100 to 1900 nanometer. So as you can see in these two graphs, the first four graphs, and this is reflectance versus wavelength, and the first four lines which are belonging to healthy samples, and the next bottom four lines which are belonging to the internally defected samples. In the lower range wavelength, you can just observe, so it can be separable. So that means healthy, just by looking at the graph. So one that we got to know that, so it can be easily separable. And when we just looked into the higher range wavelength, so it is all the lines are merged here. So it is very difficult to categorize these like healthy one and the internally defected one, especially when we consider the higher range wavelength. So we have worked with the lower range wavelength the later. Yes. Okay, so these are the techniques we have used in this model. So initially we have applied the Fisher's linear discriminant transformation. So we have used transformation technique to check so where we can get the maximum that is better result that is at lower range wavelength or higher range wavelength. So here we have taken non-zero eigenvalues, that means positive eigenvalues, and categorized or classified using Euclidean distance measure. So here in the lower range wavelength, so we got nearly 75% of accuracy. For higher range wavelength, so we have obtained nearly 50 to 60% of accuracy. Later we have worked with we have selected only lower range wavelength for our further experimentation. And later we have also used Fisher's ratio as a filter technique that is for wavelength selection, that is as a feature selection technique. And also we have used dispersion measures. So, and all these techniques which gives us the relevancy score for individual wavelength. So based on the relevancy score, so later the relevancy scores are sorted in decreasing order, and that is in descending order. Based on the relevancy score, so we have taken the top one rank or top two rank. So and considering these top one or top two or the top most features, so we have classified these samples like healthy and the defected samples using Euclidean distance measure. Next slide. Previous. Okay, as you can see in this graph, in the first part that is in Fisher's ratio, as I told, once the relevancy scores are sorted in descending order, so we have taken the cumulative rank features and classified using Euclidean distance. So you can just observe in Fisher's ratio, so we are getting nearly, that is more than 84% of accuracy by considering the less number of wavelengths. That means by having the less number of features. And when you just look at the AMGM, that is arithmetic mean and geometric mean, we are getting maximum accuracy or the better result, that is after considering 1000 number of wavelengths. And similarly, even in mean median also, we are getting the good accuracy or the better result after considering 1000 number of wavelengths. So even in MED, that is mean absolute difference, that is after considering nearly, that is more than 250 number of wavelengths, so we are getting better result. But compared to all these the Fisher's ratio, using Fisher's ratio, so we are getting better result by considering the less number of wavelengths. So with this actually further we have yes, next. So to check with the wavelength distribution, so we have plotted. So just to check with the wavelength distribution, that is considering only 135 or less number of wavelengths. So we have just plotted this wavelength distribution. We can just observe here in using the first one is Fisher's ratio. In Fisher's ratio, we have less number of wavelengths, that means 135 number of wavelengths, but it is continuous again, continuous. And when we just observe the rest of the graph, so it is like wavelengths are distributing throughout that means 700 nanometer to or 650 nanometer to 1100 nanometer. So since there is no consistent or the continuity in the wavelength in rest of the methods, that is dispersion method. So finally we have considered, or we have considered the Fisher's ratio is giving a better result, or we can have less number of wavelengths with a continuous wavelength range. That is for the classification purpose. Yes. And later, so we have tried with considering, we have tried with this classification. So that is performance, that is cumulative addition of the first, it is actually instead of first, so I can say the top 1 rank, top 2 rank, and top 3 rank. So considering the cumulative of the top 1, top 2, top 3 rank of all these techniques like Fisher's ratio and this dispersion measure. So we have calculated the accuracy. So we are getting 79% considering only top 1 rank features. Then the accuracy is decreasing, that is considering cumulative addition of first and second rank, and then third rank wavelengths. And you can just observe the performance analysis of individual for individual wavelength in Fisher's criteria. So, and we are getting 85% of accuracy, the maximum accuracy that we are obtaining at 752.52 nanometer by considering the individual wavelengths. So we have also performed classification accuracy. Yes, sir. So I wanted to share the opening issues. Is it visible, sir?
Yes, yes.
Yes, it's visible.
Okay, with all these experimentation and results, so I can say for especially for further researchers, parameters like store time, temperature, and moisture so could be studied, because we have not tried with these parameters. The analysis is not done, so this can be done in future. Because as I told, so based on the temperature, for the temperature especially during ripening process, how many like how mangoes ripen get faster, how the ripening process takes place, so how fast it gets ripened and how slowly it gets ripened. So everything can be studied. It could be studied in future. And as I've tried this FLD transformation to analyze NIR spectroscopy data, that is Fisher's linear discriminant transformation. So one can try out the different transformation techniques. So that means different transformation techniques could be tried out to analyze the NIR spectroscopy data. Next, statistics on the area and depth of the defect could be studied for internal defect detection. So here also we have just classified whether it is defected or non-defected, or whether it is defected or not defected. But so in future, so even the area or depth of the defect can be studied. Next, to look into performance factors, so we must have exhaustive experimentation on a large database. Sometimes due to the scarcity of the mangoes at the market, it will be very difficult to collect the huge number of data sets. So, and of course, if we can increase the number of samples, the system accuracy becomes consistent and guaranteed. So one can think of by having a large number of database. So thank you, one and all. Thanks for giving me an opportunity to share the research. Yes. Yes, sir.
Thank you so much, ma'am.
Yes, great.
Thank you.
Thank you so much, ma'am.
Yes.
Thank you.
So now it's time to sum up the things which we have discussed for the last roughly about 90 minutes.
Yes.
We just have started with understanding of importance of mangoes and the different post-harvest management stages, and where are the challenging issues to automate, and then how the machine learning really helps us in coming out with an automation of mango sorting. And I just touched upon general setup of machine learning irrespective of the application. And then we understood a couple of feature selection methods, fundamentally filter, wrapper, and ensembling and hybridization, where Anita madam has exploited the beauty of both filter and feature transformation method, especially FLD, and for filter case, different feature ranking criteria, techniques, and so on. She presented hierarchical way of grading of mangoes and different classifiers exploited, and different features have been studied, and then finally argued that the label color feature phase works for at one level and texture feature works at the next level and so on. And while presenting her experimentation and especially the results that she obtained, she shared her the difficulties that and the challenges she went through, especially while collecting data. So because as I said in the beginning, mango crop is a highly perishable crop. We cannot wait for a longer time. It's a natural process. She really found it very difficult to gather the data and end up with labeling of the data, especially, and every hundreds of mangoes are used to be cut and studied to generate the ground root. And before that, the mangoes was carried from Mysore to Bangalore, subject to the marine aspect and so on. And finally, good that she has also highlighted a couple of issues for budding technocrats to explore further in this direction. So we just made this presentation for the benefits of budding technocrats who are inspired to take up this machine learning towards agriculture. So with this, let me acknowledge the support rendered by my colleagues and others to make this presentation possible today, and with a special acknowledgement to the organizers of this program for having given me an invitation to deliver a keynote talk on the topic of meditation. Special thanks to Professor Raj. Thank you, one and all. Thank you very much for your patience. And thanks a lot.
Thank you, sir.
Thank you so much, sir. Thank you very much. Hello, am I audible?
Yes.
Yes. Yes. Thank you so much, sir. Now, some of the participants would like to ask the questions.
That's fine.
Some of the participants would like to ask questions, sir.
Okay.
Yes.
No issue.
Yes, Bhagya ma'am.
Thank you, sir, for a new slide for us. Sir, actually, I wanted to know that NI are spectroscopic. You said that internal defects to find out. So I wanted to know how could we consider the angular form, either it is of 360 degree. How many? How could we completely the mango has to be scanned? So just wanted to know about that.
You have to project it in all 360, right? It's good if we can have a couple of views, if not in 360. You take one or two views and then study the map.
Anyone in the audience?
So, madam,
It's one or
You need not study
yes, sir.
you need not study it in 360. You collectively choose
Yes.
only in the discrete, interval.
Yes.
2 to 3 views are good enough.
Okay, sir. Thank you.
Yes.
Yes. Anyone in the audience like to ask a question? Sir, question, sir.
Yes, please.
Yes, sir. Sir, I'm working on hybrid way of feature extraction. Nowadays, the hybrid way of extraction is in all the researchers are following maximum this way. So, is the best way to go for hybridization to just
What are you trying to hybridize for? What purpose?
yeah the
basically feature selection is different, feature extraction is different. Feature extraction is a kind of transformation.
Yes.
Feature selection is a subsetting.
Yes.
You go for hybridizing a feature selection method with feature transformation.
Okay.
What is your primary target?
To get the best results.
On what? What is your application domain? Did you
Sir,
study individual feature selection, individual feature transformation?
yes, sir. I have gone for my images, for my work. I have gone through the feature selection methods like hog, shift, and other methods. So when I went with an hybridization, so that gave me the better result.
What you are telling is descriptors, image descriptors.
Feature descriptors, yes, sir.
Yes,
Feature
yes,
descriptors.
that image descriptors,
yes,
and then you just have thought of
Yes.
combining them with a concatenation, right?
Yes, sir. Perfect.
Yes. When you concatenated different, kinds of features together into a single feature vector, then obviously end up with a huge name.
Okay, sir.
Okay.
Yes, sir.
Then you can try out many possible ways of filtering it out, filtering unwanted and retaining only wanted. Make a case study with your sample space.
Yes, sir.
That's good. You can conduct an experiment and demonstrate that.
Yes.
The sequence with which you try out different feature selection criteria would work.
Okay, sir. Thank you so much.
So hybridization is required only when you want to take opinions from different models. Otherwise, not required.
Okay, sir.
Understand?
Yes, sir. Yes, sir. Thank you so much. And thank you so much for sharing such a valuable research work. And it was very helpful for all the researchers who are here to get knowledge about such a deep work. And I felt it's a very big work what you have done.
Thank you. Very pleasure. It's our pleasure. In fact, that's
Yes, sir.
give it to the next generation.
Yes, sir. With this, the other researchers at least they'll get an idea like what we have left out and what we have to do with. It's a very thank you for sharing such a valuable knowledge with us. Sir. Thank you so very much.
For any kind of guidance and direction, I request all of you to drop me a mail.
Yeah, definitely, sir. Definitely. And sorry for the inconvenience what happened in the morning sessions.
That's okay.
But,
No issue. It happens. It happens. That's life.
Yes. Thank you very much, sir, once again. And thank you, Anita madam, also for joining us and sharing her work. Thank you so very much. We will hope to see you again in our next webinars and